question 3 in your workbook. All right, and now we are dealing with, we need to be able to identify those as parabolas. And when we see those, what needs to come to mind? The standard form for our parabolas: y is equal to a x squared plus q. That needs to mean something to you, and that needs to mean something to you. You need to know exactly how that affects the graph. All right, study the graphs below and answer the following question. So let's first study the graphs. We've got the graph of F, the orange one, that's a happy face parabola. And then we've got graph of G, the blue one, that is a sad face parabola. Now, what I notice is that I was not given the turning point, which is the same as the y-intercept for graph G or for F. Okay, so we're going to have to do without those. I got given on the blue graph a random point of 2 and -6, and I was also given the x-intercepts of -1 and 1. And then for the orange graph, graph F, we were given one of the x-intercepts, -2, and since they are a mirror image of one another, we would also be able to say that that one is 2. And then we got given that random point of -1 and 3. Okay, yeah, I think that's pretty much it. I do feel the need to go add those. And then we're going to look at the questions and jump in. All right, for 3.1, let's see what they say. Find the equations of the parabola. So we need to find the equation for both. We need to find the equation for F and then for G. Obviously, it doesn't matter which one we start with. Let's start with F. So we are going to find the equation of f of x in the form ax squared plus q because it is a parabola. Now, these are the trickier ones where you have to find the equation. And why do I say that? It's because we were not given the q. We were not given the turning point, which would have made this a whole lot easier. So let's see how we're going to tackle this. So since there's two parameters that we need to find that q value and we need to find that a value. If we plug in one of the points that we got given, so let's say I'm going to go plug in that point, -2 and 0, into my equation. See what happens. So there I put my 0, and into my place of x, I put my -2, and that's it. Let's just simplify that. That would give me +4, a plus q. Now, students think that it's something wrong or they give up when they see that there are two missing things that we need to find. You are on the right track. That is perfectly fine. What we'll need to do is we will need to substitute another point, and we're going to have to do simultaneous equations. So when do we use this method? When we're not given the turning point and we just can't go plug something straight into Q. So I'm going to go substitute a second point that was given on my orange graph, which is the point -1 and -3. And when I substitute that in, there's my y, there's my x. Let's simplify. And that will just give me a +1. Okay, and same story. We've got a second equation in terms of a and q. So when you did equations, grade 10s, and most of the time, the examples you saw was most probably two different equations with x and y, and you had to find x and y using simultaneous equations. But it's the same thing. The two variables are just a and q. So we've got two equations in terms of a and q, and we need to go solve it now. Now, please, over here, how you do your simultaneous equations is completely up to you. You can do elimination, you can do substitution, you can do whatever you want. I'm going to just do it in one way. So do it your way and make sure that you are comfortable with simultaneous equations and just make sure that you and I get the same answers. So what I'm going to do with this one, I'm going to isolate my q. So I'm going to isolate my q, and that means that I will just have to take that one over, right? So it's as simple as that. And then with this one, I think what I'm going to do is I'm also just going to isolate my q by taking that one over. All right, again, you do your method, but how I'm going to think about it is I'm going to say, okay, well, q is equal to this, and q is also equal to that. So then surely these two things must also be equal to each other. Think about that. Q is that, q is also that. So therefore, these two things must also be equal to each other. So now we have an equation that is only in terms of a. So we can solve a. I am going to plus 4a on this side, but then I also just have to plus 4a on that side. Then I'll be left with 0 is equal to negative 3, and that would be plus 3a. Also, how you decide to solve this equation is completely up to you. Not just one way of doing it. I divide both sides by 3. Doing functions relies heavily on equation knowledge. So I found my a to be 1. We're almost done. Now we just need to go find q. And we can use either one of the equations to do that. We can plug it in there. We can plug it in there. Does not matter. Okay, so I'm going to go plug it into, I'm just going to go plug it into equation 1, I think. So if I plug the a that I just found into my equation 1, 0 is equal to 4 times, there's my a that I just found, plus q. 0 is equal to 4 plus q, and then q must be equal to negative 4. Ask yourself, grade 10s, does it make sense that my q is a negative value for my orange graph? I definitely think so, if we look at that over there. Okay, perfect. So we found our equation for f of x. So for f of x, it is equal to 1a is 1, so it will just be x squared, take away 4. There we go. Now we need to go and find, the other one is g of x. All right, let's do that. For g of x, again, we were not given the q. We were not given our turning point, so we're going to have to do the same thing. Let's go plug in. The first point that we're going to go plug in is 0 and 1. Doesn't matter which one you decide to plug in. So in the place of y is 0. In my place of x is 1. And there we go. So far we've got a plus q. We are left with an a and a q. We couldn't solve either one. That's okay. Don't think you're doing something wrong. We just go plug in a second point that was given on our blue graph, the point 2 and negative 6. When my y is negative 6, my x is 2, and there we go. Let's simplify that. So we've got 4a plus q. And again, we've got a second equation in terms of a and q, so we are going to have to use simultaneous equations. There's my first equation. There is my second equation. And again, grade 10s, you do however you understand this. Refer back to simultaneous equations if you must. So important. I think what I'm going to do is I'm just again going to isolate my q by just taking my a over. And over here, I am going to do the same because the coefficient of q is just 1. So that just makes it easy, I think. I'm going to take that one over, and there we go. I isolated my q, and same story. If q is equal to that, and q is also equal to that, then surely these two things are equal to each other. So negative a is equal to negative 6 take away 4a. I've got an equation only in terms of a, which is great, because then we can solve it. I'm going to plus 4a on this side so that they cancel out and it goes away as long as I do it on the other side. So then on the other side, I get 3a, and that side I'm left with a negative 6. Now I divide both sides by 3, and then I get negative 2. Okay, so I found my a. Don't stop there. We still need to find our q. And I am going to plug in to equation 1 again. Doesn't matter which one you plug into. But into equation 1, in the place of a, let me just use a black there. In the place of a, I'm going to plug in a negative 2 plus q. And then q is equal to 2. So there I found both a and q, and we found our equation. Therefore, our g of x, our blue graph, is equal to negative 2x squared plus 2. Now, if we think about that, grade 10s, it makes sense that our y value, or our q value, our y-intercept there and our turning point is a positive. And sad face, it makes sense that our a is a negative 2, so it lines up. So now we've got f of x and we've got g of x as they asked us to find. All right, we use simultaneous equations. This can definitely show up. Make sure that you're comfortable with that. Question 3.2 says, find where f of x and g of x are equal to each other. So we need to find where those 2 points are equal to each other. We can do that because they are looking for those points where they are equal to each other. Which 2 points do those 2 graphs share? And we literally need to go do what they're asking us to do. We need to make them equal to each other. So we take the equation of f and we make it equal to the equation of g. And this is also quadratic equations grade 10. So heavily relies on our quadratic equation knowledge. Okay, let's see how we're going to solve this one. Well, since this is a quadratic equation, I will get everything to one side and see if we can maybe factorize. Let's give that a go. I am going to plus 2x squared on this side so that that goes away just as long as I do it on the other side as well. So then I've got 3x squared over there. And then I am going to subtract 2 there so that that cancels out and I'm left with the 0 there. But then I must just do the same. So then we are left with negative 6 there. So however you do that and think about that, make sure that you get to that same point. Now I am going to, what am I going to do? Am I going to take out a common factor of 3? And then I've got x squared minus 2, like that. And then I can divide both sides by 3. I divide the left by 3, then I'm left with that. And if I divide the right-hand side by 3, 0 divided by 3 is still 0. Okay, well, I think the best way to go about this one over here is then to maybe just take this one over. I think this is how you would do it. And if you do it differently by reaching for your calculator or whatever, that's perfectly fine. And then to get x by itself, I get the square root on both sides. And therefore, x is equal to plus or minus the square root of 2. Now, we can just leave it at that. In order to, if we have to go plot that, we will need to put that into our calculators and see what that is equal to, maybe 1 comma whatnot. I'm actually going to put it into my calculator before I... 1.414, blah, 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 blah. So you can leave it like that over there. But when we go plot it, we just quickly put it into our calculator to see, okay, 1.4, that we know more or less where it is and if it makes sense with where we're at on the graph. And I think it actually does. Okay, but we found the x values now. So this one would be negative square root 2. And that point over there would be positive square root 2. But we still need those y values. And how are we going to find those y values? We need to plug it into the graphs, but which one? Either one, because that point is on both graphs. So I'm just going to use f of x. So first into f of x, which is that graph. So into that function, I am going to plug into the place of x, I'm going to plug a square root of 2. So into the place of x, I plug in square root 2, and then that is squared. And then the square root of that just gives me 2. And if I take away 4, it gives me a negative 2. So when I plug in a positive square root 2, I'm going to get out a negative 2 there. So that must be a negative 2 over there. Now, obviously, we can go and plug in the other one as well. But these are mirror images. The y value on the other side is going to be exactly the same. But let's just show that anyway. So negative square root 2 is equal to negative square root 2 that's being squared, take away 4. So if I square that, it's going to give me a positive 2 anyway. So it's going to give me exactly the same. And there we found the coordinates of the points of intersections of where the graphs are equal to each other. Very popular question.